exam question revision video for GCSE. 2018 Summer Higher Tier Unit 2 Question 11 Volume of a Pyramid. The question says, calculate the volume of a pyramid with base area of 13,200 centimeters square and a perpendicular height of 460 centimeter. Give your answer in meter cube. Thinking. The volume of a cone is 1/3 the volume of the cylinder with the same base. We know that. We've been given that in the front of the examination paper. But is the volume of a pyramid 1/3 the volume of a cuboid with the same base? Well, if you have a look at this three-dimensional cube, and you can see they've fitted three pyramids into this cube. There's the base of one up to that corner. There's the base of another one up to that corner. And then the base of the bottom up to that corner. So yes, but we can prove it properly using calculus. And this is a further maths A-level subject. The units are in centimetre and the answer is needed in metre. So we can either calculate in centimetre and convert to metres at the end, or change everything to metres at the start of the calculation. We're going to do everything in centimetres to start. So the volume of the pyramid we've decided is 1/3 of the area of the base times the height. So the area of the base is 13,200 centimetres square. The height is 460. Multiply those and divide by 3, and we get 2,024,000 centimetre cube. Now we need to convert that. So 100 centimetre is the same as 1 metre. Therefore 100 centimetre all squared would be the same as a metre squared. That's in 2 dimension. And similarly, giving us 10,000 centimetres squared. For a metre cube, we need to cube 100 centimetre, and that would give us 1 million centimetre cubes would be within 1 metre cube. That's in 3 dimension. Therefore, changing our centimetre cube, we get 2.024 metre cube. Changing everything to start, we get 100 centimetres is a metre. So 100 centimetre all squared would be a metre squared. So that would give 460 centimetre would be 4.6 metre, and our 13,200 centimetre squared would be 1.32 metre squared. So using the formula, third area of the base is 1.32 metre squared. Area, the height would be 4.6 metres. Multiply those, divide by 3, and we get 2.024 metre cubed. So either method. Another question relating to volumes. The diagram shows a solid metal cylinder. Cylinder has a base of 2x and a height of 9x. Cylinder is melted down and made into a sphere of radius r. Find the expression for r in terms of x. So thinking about this, we need the volume of a cylinder. We need the volume of a sphere. And the volume of the cylinder will be equal to the volume of the resulting sphere. So we know from the front of the exam paper that the volume of a prism is the area of the cross-section times the length. Well, our cylinder is a prism with a circular cross-section. So we need the area of the circle multiplied by the height to give us the volume of the cylinder. The area of the circle, you know, is pi r squared times the height. I put that r in blue because it's not the same r as in the radius later on. So our radius for the circle is 2x, so pi times 2x all squared times 9x for the height, giving us bracket squared gives us 4x squared, so 36 pi x cubed for the volume of the cylinder. The volume of a sphere is 4/3 pi r cubed from the front of the exam paper. So we need to put that equal to 36 pi times x cubed. And you can see there's a pi on both sides, so we can divide through by pi. And then if we multiply both sides by 3/4 to get rid of the fraction, we'll get r cubed is 3/4 times 36x cubed, giving us 27x cubed. I can take the square root of that, so r would be 3x. There's no units given, so we can leave the units out. Another question slightly different. The diagram shows a frustum of a cone. That's a cone with the top bit sliced off, parallel to the base. The height of the frustum is 10 centimeters. The radius of the base is 8 centimeters. The radius of the top is 3 centimeters. Find the volume of the frustum. So thinking, we need the volume of a large cone. We need the volume of a small cone to take away. The small cone would have been on top of the large cone. We need the height of the small cone and the height of the large cone. So we're given at the front of the exam paper, the volume of a cone is pi r squared times the vertical height. So if we draw a diagram of the cone as it would have been before the top bit was taken away, and we call the height of the small cone x, then the height of the big cone would be x plus 10. So the volume, they're similar shapes, so the ratio of the sides will be equal. So we've got a 3 and an 8, so the ratio 3 to 8 or 8 to 3 would be similar to the x over x plus 10. If you start with the 3, you must start with the x on the other side. So the small to the big equals small to the big, or the other way around. If I multiply both sides now by the x plus 10 and by the 8, I will get 3x plus 10 is equal to 8x. Multiply out, I get 3x plus 30 is equal to 8x. So 5x is equal to 30, x is equal to 6. So the height of the big cone is 16. The height of the small cone is 6. So the volume of the big cone is 1/3 pi times 8 squared times 16, giving us 1072.33 centimeters cubed. And the small cone is 1/3 times pi times 3 squared times the 6, giving us 169.646 centimeters squared. Take those away, so our frustum is 902.68 centimeter cubed. So just a different type of question involving volumes.